Hi guys, today we're going to solve this problem in LeetCode called power of 2. So let's read the problem and then give it a try. So what we have is an integer n and we need to return true if it is a power of 2. Otherwise, we return false. So an integer n is a power of 2 if there exists an integer x such that n equals to 2 raised to x. So that means if n is equal to 1, output is true because 2 raised to 0 is 1. If we have 16, then that's true because 2 raised to 4 is 16. If n is 3, the answer is false. N is 4, the answer is true. N is 5, the answer is false. So with this, we are given the input and the output. Let's read the constraints as well. Constraints are that the value of n ranges from minus 2 raised to 31 to positive 2 raised to 31 minus 1. Now I'm going to solve this problem using recursion, and I'm also going to use this concept called the tail recursion. So here's my whiteboard, and I'm going to solve this problem using tail recursion. So in this problem, we need to look at this part that if at all we are given x raised to n, or actually if I clear off this whiteboard and if you're given 2 raised to 0, then that happens to be 1. So what we need to do is we need to continuously divide this number to keep finding out smaller and smaller values of this value. So say for example, we're given 2 raised to 2, which is 4. So I keep dividing this by 2. So we do integer division. So this comes out to be 2. And then this will form one of the base cases. Similarly, if we have 8, which is 2 raised to 3, so I divide that by 2 doing integer division, which comes out to be 4, which comes out to be 2, and so on. Now, we may be wondering that what if we are given an odd number like 3? So in this case, when we do integer division, then we land up with 1. And if that is the case, we need to return false. Also, if we have our n to be something like 18, which is an even number. So here, if we divide this by 2, we land up with 9. Now, once 9 comes, then 9 divided by 2, we land up with 4. But then, at this point, we have a mod as well. The 9% 2 is going to be 1. So we need to check for this case as well. So now we have a pretty fair idea how this has to be done. So what's going to happen is our base case is going to be if n is equal to 1 or n is equal to 2, we're going to simply return a true or false. Else, we keep dividing n by 2 and also take the modulus of n. This helps to check if n is even or odd. So we are also using this concept called tail recursion. By tail recursion, what we mean is that we do all the steps in a particular function and the recursion is left at the end. So for example, if we have a function like this and say it is getting past n, so we have a sequence of all the steps and the end we have something like, okay, n minus 1 or n by 2 in this case. There's nothing after this. So this is tail recursion. So the advantage of tail recursion is that most compilers and interpreters are optimized for this tail recursion. And it is a little bit faster compared to regular recursion. So now let's write the program to get the result. So here I have the LeetCode problem. So what I'm going to do is initially I'm going to first check if at all my value is less than or equal to 0, because this negative number doesn't make any difference, because it simply is going to return a false if that is the case. So we can just keep a check here saying if n less than equal to 0, return false. Now, in order to achieve tail recursion, what I'm going to do is I'm going to initialize a value called val. I'm going to initialize that to true. And I'm also going to take the absolute value of n. I'm going to declare a helper function which takes in two values, the value of n and val. I'm going to call this particular helper function with this absolute value, which I calculate out here, and the value of val. Now, as discussed earlier, we're going to check for the two base cases. So in case n is 1 or n is 2, I am simply going to return val. Otherwise, I'm going to keep dividing n by 2. I'm going to do integer division and also calculate modulus. So after we run this problem via LeetCode, we're also going to go through whiteboard and see how this works in practice. Here we check if n underscore div %2 is equal to 0 and n underscore mod is equal to 0. What this helps with is finding out if the result of our integer division, did that result in an even number, and we also calculate the modulus for that. So if that is the case, then val is equal to the original value of val and true. So in case, since we initialize this to true, true and true will become true itself. And if it is not the case where we're given odd numbers, then I will give it false. And after that, I'm going to call my tail recursion on helper, pass this value, give it val, and I'm done. So now let us run this code for some sample values. Okay, so that's a little mistake that I made. So I just need to put this inside. So we're given a value of 1 and we get the result of true because 2 raised to 0 is 1. Let's try with 2. So I can get a value of true. If we get 3, value is false. If you are given 4, the value is true. Now let's try for something higher like 18, where the value should be false. Okay. And how about something like 64, which is a power of true, and the value should be true. So I've submitted enough test cases for positive values. I'll also put something for negative. So in this case, the answer should simply be a false. Okay. Now I'm going to go ahead and submit the results. And now we have our result has been submitted and it has been accepted. Now I want to go back to the drawing board once again and show you how exactly is this working. So let's take the example of a value where n is equal to 2 raised to 2 or 4. Now what is initially happening is that the function gets a value of 4 and then a check is made whether the value is 1 or 2. It is not. So what we do is that we first calculate n underscore div, which is going to be 2. We calculate the mod value, which is 0. And then we do a check saying that if n underscore div is 0, n underscore div percent 2 is 0, and n mod is 0, then we make val as val into true. So val at this point remains true. And then we call this function again. So we're calling this with a value of 2. Now at this point, we again calculate n of div. So n of div becomes 2. So now we don't need to further calculate it because we reached the base case. So we don't need to do this step. Once the base case has been reached, we just return this value. So the value becomes true. Now, how about we take the case for something higher, like say n is equal to 8. So let's have a run for that. So in case n is equal to 8, we're calling a function with the value of 8. The check is made whether n is 1 or n is 2. It's not, so n underscore div is calculated, which happens to be 4. N underscore mod is calculated, whose value happens to be 0, because 8 modulus 2 is 0. And since both of them are satisfied, the value of val becomes true. Helper is called, or in this case, function is called with the value of 4. Now, with 4 again, we make a check whether it's 1 or 2. It's not. So we do n underscore div. So it is we do integer division and we land up with 2. N underscore mod is 0. Val still remains true. And we call helper again with a value of 2. So bear in mind, I'm just using the function fun, not helper, because helper is a bit long to write. Now, when we reach function, we make the check again to see if it's true. If that is the case, we simply return the value of val, which in this case happens to be true, and we get the answer. Now, how about a case where we pick up something like, say, 6, for example. Now, bear in mind, 6 is an even number. And as we keep dividing by 2, it will come out to be an odd number. So if you're given n is equal to 6, we initially start with 6. If you do a check whether n is 1 or 2, it's not. We find out n underscore div, which turns out to be 3. Find out n underscore mod, which happens to be 0. Now we do the check saying, is n underscore div percent 2 equal to 0? No, it's not, because it turns out to be 1. So we go to the other case and make val be false. And we call the function with 3 and false. Now once this is called, what we do is we again calculate n_div 3 integer division by 2 happens to be 1, n_mod again happens to be 1, and then we make the check saying is n%2 equal to 0 and n_mod equal to 0. So it's not. Val still remains false, and we again call helper with a value of 1 and false. And the moment this is called, we make the check saying if n is 1, it is, we return the value of val, which is false. And there we go. That's our answer. And so on. So this value, this calculation also happens for values such as 18, which will get reduced to 9, which is odd, which will eventually turn up to be 3. Similarly, this will also happen with things like, say, 22, which will turn out to be 11, and 11, the end-div part will turn out to be 1 eventually, and so on. Now, the time complexity for this can be found out by writing the recurrence relation. Now, if you write down the recurrence relation for this, what we're actually doing is we are dividing the value that has been provided to us by 2 all the time. So if I were to write the recurrence relation, it would be t in by 2 plus some constant amount of work. So what's happening is that at every point, I'm taking some constant value and I keep dividing this again and again by 2. And then again, I have some constant amount of work. Again, I do some constant amount of work. And then again, I divide by 2. So this keeps continuing. And now we remember that when our initial value is divided by 2, then it turns out to be log n work. So in this case, the time complexity is going to be log n. So that's what it is. And thank you all for your time.